Okay, let's kind of boil this down to two different topics. What we call the triangle inequality, and then we want to look at how do the sides of a triangle compared to the angles of a triangle. So let's look at the triangle inequality first, and I've always thought this was really fun. So the question is, can you make a triangle out of, let's say, something that's 10 inches, 12 inches, and 30 inches? Does that actually make a triangle? And you're like, okay. So I have something and I could lay my 30-inch side down, and then I could put my 10-inch side there, and then my 12-inch side there, and oh, nuts. There's just no way that those are going to connect, right? I mean, 10 and 12 are just too short to connect to 30, and I mean there's no really other way to bend this 10 and 12. Even if I put them almost straight down, there's still going to be a gap. So the question is, okay, so no, this is not going to work. This not going to work. What if it was 10, 12, and let's say 18? You're like, oh, well, I think that's going to work, right? I can put something 18 down, and then 10, I could bend it up at 10, and then I could bend that one at 12. Those are going to reach, right? So what determines whether something makes a triangle, like this one can make a triangle, and this one can't? Well, it turns out that if you give me two sides of a triangle, I can tell you an inequality, a range of what the other side might be. Okay, so let's kind of walk through this. Let's say I have sides 5 and 8. Okay, and I'm looking for the other side. And let's say that the other side, in this case, is the longest side. Okay, so what's the longest x could be? Well, if I laid x flat and I reached the 5 this way and the 8 that way, and they were almost flat, well, how long would that one be? Well, wouldn't that one have to be bigger? Excuse me. If that one was 13 or bigger, there's no way they would stretch, right? This can't be like 20 or 100, right? This side has to be smaller than 13. Otherwise, the 5 and the 8 won't reach. Okay, well, what if x was the smallest side? So this was 8. And then this guy was 5. What would that guy have to be? Well, that would have to be bigger than 3. Otherwise, it won't reach. Okay? Well, what if x was the middle? Well, if it was the middle, it could clearly, it's already in those ranges. We really just want to look for that second side. What's the larger bound? And then the smaller one. So pretend x is the biggest. It can't be any bigger than 13, and it can't even be 13. Otherwise, the 5 and 8 won't stretch. If x is the smallest side, 8 then is the biggest side, and it can't be 3. 3 and 5 won't stretch to make 8. They have to have a little angle to them, so it's got to be bigger than 3. So then we say, what is x? X has to be bigger than 3 and yet smaller than 13. Okay, and again, let's do another example. Let's say it was, and I would always write them in this order. Let's say I had 10 and I had 14. Okay, I'm going to look at the first case. What if x was the biggest? So pretend that guy was x, and you lay the 10 down and you lay the 14 down. You're like, okay, x cannot be bigger, can't be 24, and it can't be bigger than 24. If x was like 100, it's not going to work, right? X has to be less than 24. Less than 24. And if it was the other way, if x is the small guy, that means 14 is the big guy, and you got 10 laying here, and you got x laying here. Well, x has to be at least 4, but it can't actually be 4. It's got to be bigger than 4. Otherwise, 10 and 4 won't make it. So what do we say? It's got to be bigger than 4 and less than 24. And it does make sense that this number is 10 plus 14, and this number is 14 minus 10. I'd rather you not actually just memorize that, that you're adding the numbers and subtracting. I would love for you to be able to draw these two pictures. Draw this picture, and like, well, it can't be bigger than 24. I mean, actually, it's got to be less than 24. And over here, this guy has to be at least 4, otherwise it won't hit. And so we get, when we say the triangle inequality, we're talking about those two things. So you're going to write a compound meaning there's two of them, inequality that describes what will make a triangle. Okay, so you have to decide. If I just give you all three, you either say, no, it can't, because that's bigger than this plus this, right? So in the deciding whether it might make a triangle, you have to have the two small ones. A plus C has to be greater than C. Again, 10 plus 12 has to be greater than 30, otherwise it's not going to hit. Again, 10 plus 12 is greater than 18. We'll just draw it out. That will make a triangle. And again, this is where A and B are the small ones, and C is the biggest. If I just give you two of the sides, you have to be able to find, well, how big could the third side be, or how small could the third side be? And so there's two different cases. You can draw the triangles, and then you got it. Okay, the other thing that we want to point out, and I will probably do some GeoGebra thing, that if you draw, sorry, I'll get that back in order. If you draw a triangle like that, and this is the small side, this is the medium side, and this is the large side, okay, you will notice that if we take the angle measurements of these guys, that where do you think the smallest angle is? Well, the smallest angle is across from the smallest side. The large angle, largest, or large, is across, again, across. Small is across from the small side, and then the medium is across from the medium angle. Okay? You don't have the tools right now to actually find them, but you do have the idea of ordering them. Okay? So if this is angle A, this would be side length A. If this is side length C, this would be angle C. For angles, we use uppercase letters. For side lengths, we usually use lower. So the small one would be B, and then this would be angle B. Okay, and so what we might say is, if C, side length C, is greater than A, and A is greater than B, right? This is me ordering the sides. Then you know for sure angle C is greater than angle A, which is greater than angle B. Angle B is the smallest angle because it's across from the smallest side. Angle A is in the middle because it's across from the medium side. And then angle C, we don't know what it is, but it is for sure the largest of the three angles because it is across from the largest side. So when I said side versus angles, we're talking about knowing like relatively speaking, how big they are from each other. The big angle is across from the big side. The small angles across from the smallest, and so on. And again, there are future things we can look at to actually decide how big angles are versus sides and such. But right now, we just want you to know what makes a triangle, right? Can't make a triangle, can make a triangle. And then if I give you two sides, you can write an inequality that says, okay, what can that third side be? Well, if the first two sides are 5 and 8, the third side cannot be 13, strictly less than, right? Not less than or equal to. It can't be 13, and it can't be bigger than 13. But it also can't be 3, and it can't be smaller than 3. It's got to be in that range. And then we also want you to be able to order the sides and the angles based on, if you know the side lengths, then you know the angle order. If you know the angle order, then you know the side length order.